Welcome. Today, we are looking at the periodic table. This is a key topic in your chemistry exams for SS1. Pay close attention. Let us begin. First, let me explain what the periodic table is. The periodic table is a tabular arrangement of the chemical elements. It organizes elements by their atomic number, electron configuration, and recurring chemical properties. The periodic table was first developed by Dmitry Mendeleev in 1869. He arranged the elements in order of increasing atomic mass. He noticed that elements with similar properties appeared at regular intervals. He called this periodicity. Mendeleev left gaps for undiscovered elements. He predicted their properties. When the elements were discovered, they matched his predictions. This confirmed the power of the periodic table. The modern periodic table is arranged by atomic number. This was done by Henry Moseley in 1913. The modern periodic table has 7 periods and 18 groups. The periods are the horizontal rows. The groups are the vertical columns. Elements in the same group have similar chemical properties. This is because they have the same number of valence electrons. Now let me explain the structure of the periodic table. The periodic table is divided into periods and groups. The periods are numbered 1 to 7. Period 1 has 2 elements, hydrogen and helium. Period 2 has 8 elements, from lithium to neon. Period 3 has 8 elements, from sodium to argon. Period 4 has 18 elements, from potassium to krypton. Period 5 has 18 elements, from rubidium to xenon. Period 6 has 32 elements, from cesium to radon. Period 7 has 32 elements, from francium to oganesson. The groups are numbered 1 to 18. Group 1 is the alkali metals. They are very reactive metals. They have 1 valence electron. Group 2 is the alkaline earth metals. They are reactive metals. They have 2 valence electrons. Groups 3 to 12 are the transition metals. They are less reactive. They have variable valence. Group Sitten is the halogens. They are reactive nonmetals. They have 7 valence electrons. Group 18 is the noble gases. They are unreactive. They have 8 valence electrons, except helium, which has 2. The elements in the same group have the same number of valence electrons. This gives them similar chemical properties. Now, let me explain the trends in the periodic table. There are several important trends. Atomic radius is the size of an atom. Atomic radius decreases across a period from left to right. This is because the nuclear charge increases. The electrons are pulled closer to the nucleus. Atomic radius increases down a group from top to bottom. This is because new shells are added. The electrons are further from the nucleus. Ionization energy is the energy needed to remove an electron. Ionization energy increases across a period from left to right. This is because the nuclear charge increases. The electrons are held more tightly. Ionization energy decreases down a group from top to bottom. This is because the atomic radius increases. The outer electrons are further from the nucleus. They are held less tightly. Electron affinity is the energy change when an electron is added. Electron affinity increases across a period from left to right. This is because the nuclear charge increases. The atom attracts electrons more strongly. Electron affinity decreases down a group from top to bottom. This is because the atomic radius increases. The incoming electron is further from the nucleus. Electronegativity is the ability of an atom to attract electrons. Electronegativity increases across a period from left to right. This is because the nuclear charge increases. The atom attracts electrons more strongly. Electronegativity decreases down a group from top to bottom. This is because the atomic radius increases. The nucleus is further from the bonding electrons. Now let me explain the groups in more detail. Group 1 elements are the alkali metals. They include lithium, sodium, potassium, rubidium, cesium, and francium. They are soft, silvery metals. They have low melting points. They are very reactive. They react with water to form hydrogen gas and an alkaline solution. They react with oxygen to form oxides. They react with halogens to form salts. They have one valence electron. They lose this electron to form positive ions. Their reactivity increases down the group. Potassium is more reactive than sodium. Cesium is the most reactive. Group 2 elements are the alkaline earth metals. They include beryllium, magnesium, calcium, strontium, barium, and radium. They are harder and denser than alkali metals. They have higher melting points. They are reactive, but less reactive than alkali metals. They have two valence electrons. They lose these electrons to form positive ions. Their reactivity increases down the group. Group 17 elements are the halogens. They include fluorine, chlorine, bromine, iodine, and astatine. They are nonmetals. They have 7 valence electrons. They gain 1 electron to form negative ions. They are very reactive. They react with metals to form salts. Their reactivity decreases down the group. Fluorine is the most reactive. Iodine is the least reactive. They exist as diatomic molecules. Fluorine is a pale yellow gas. Chlorine is a greenish-yellow gas. Bromine is a red-brown liquid. Iodine is a dark purple solid. Group 18 elements are the noble gases. They include helium, neon, argon, krypton, xenon, and radon. They are colorless, odorless gases. They have 8 valence electrons, except helium, which has 2. They have full valence shells. They are very stable and unreactive. They rarely form compounds. They are used in lighting, welding, and as inert atmospheres. Now, let me explain the periods. Period 2 elements include lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Period 3 elements include sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. The properties of elements change across a period. Metals are on the left. Nonmetals are on the right. Metalloids are in the middle. Metalloids have properties of both metals and nonmetals. The elements become less metallic across a period. They become more nonmetallic. The reactivity of metals decreases across a period. The reactivity of nonmetals increases across a period. The atomic radius decreases across a period. The ionization energy increases across a period. The electronegativity increases across a period. Now let me explain the position of hydrogen. Hydrogen is a special element. It is placed at the top of group 1, but it is not an alkali metal. It is a nonmetal. It has 1 valence electron. It can lose 1 electron to form a positive ion. It can also gain 1 electron to form a negative ion. Hydrogen is unique. It is the most abundant element in the universe. It is found in water, organic compounds, and many other substances. Now let me explain the importance of the periodic table. The periodic table is an essential tool for chemists. It organizes the elements systematically. It allows chemists to predict the properties of elements. It shows trends in atomic radius, ionization energy, electronegativity, and reactivity. It helps chemists understand chemical bonding and reactions. It is used in research, industry, and education. The periodic table is one of the most important achievements in chemistry. Now let me explain the concept of periodicity. Periodicity is the repeating pattern of properties in the periodic table. Elements in the same group have similar properties. This is because they have the same number of valence electrons. The properties repeat at regular intervals. This is called periodicity. For example, the alkali metals are all soft, silvery, and reactive. The halogens are all reactive nonmetals. The noble gases are all unreactive. Periodicity is the basis of the periodic table. It allows chemists to make predictions about unknown elements. A common exam question asks you to describe the periodic table and explain its arrangement. Here is a sample answer. The periodic table arranges elements by atomic number. It has 7 periods and 18 groups. Elements in the same group have similar properties. They have the same number of valence electrons. The periodic table shows trends in atomic radius, ionization energy, electronegativity, and reactivity. Mendeleev developed the first periodic table. The modern periodic table is arranged by atomic number. Another exam question asks you to explain the trends in the periodic table. Here is your answer. Atomic radius decreases across a period and increases down a group. Ionization energy increases across a period and decreases down a group. Electronegativity increases across a period and decreases down a group. Reactivity of metals increases down a group and decreases across a period. Reactivity of nonmetals decreases down a group and increases across a period. These trends are due to changes in nuclear charge and atomic radius. Another exam question asks you to give the properties of groups 1, 2, 17, and 18. Here is your answer. Group 1 elements are alkali metals. They are soft, reactive metals with one valence electron. Group 2 elements are alkaline earth metals. They are harder, less reactive metals with two valence electrons. Group 10-7 elements are halogens. They are reactive nonmetals with 7 valence electrons. Group 18 elements are noble gases. They are unreactive gases with full valence shells. Each group has characteristic properties. Let me give you a quick summary. The periodic table arranges elements by atomic number. It has 7 periods and 18 groups. Elements in the same group have similar properties. The periodic table shows trends in atomic radius, ionization energy, electronegativity, and reactivity. Group 1 are alkali metals. Group 2 are alkaline earth metals. Group 17 are halogens. Group 18 are noble gases. Hydrogen is a unique element. Periodicity is the repeating pattern of properties. Practice these concepts. When you have them down, move to topic 9.